Hello. So in this video, we are doing composition. We're doing it a little weirdly, right? So we know f of g of x and we know g of x. We want to know f of x. So normally, right, we start with some f of x. Then to get f of g of x, right, to get f of g of x, to get this, we would take that f of g of x and we replace x with g of x, and then replace g of x with its definition. There's no apostrophe there. That was a reflex. Okay. So I mentioned this because we're going to do that same process, but backwards, right? So we're given f of, I guess, let me be actually consistent with what I wrote over there, just for everybody's sanity. So we're given f of g of x, and I'm going to write it in a different color because we don't know what part is what at this point, which is sort of the point, right? So we have that this thing is e to the 4 times, and then we have x minus 4 squared plus 5. Yeah, it's kind of hard to see from here whether that's a plus 5 or minus 5, but looks like a plus 5. Okay, so we have this bit, and we also know, right, we're also given that g of x is x minus 4 squared. So here, the last step, right, we're doing this but in reverse. So the last step was to replace g of x with what it's defined to be. So doing that backwards, we want to find what g of x is defined to be and replace it with g of x. So we look through here and we try to find something that looks like x minus 4 squared, and voila, that's what we see. So we're going to take this bit and replace it with g of x. And that's good, right? That's useful because what that tells me is that everything else is really the f. So the f is going to turn out to be something like e to the 4. That then gets replaced with g of x, and I get plus 5. But even if we didn't sort of know already that that was f, like if we're still unsure, we can still write this. That's definitely true, and we'll keep unraveling. So next part, right? So we undid this step, so we're going to undo this step, which should get us back to f of x. So notably, I'm not going to keep computing here because that's f of g. I'm just going to claim f of x is what I have once I undo this step, once I undo g of x back to x. So anywhere I see g of x, I replace it with an x. So here, I'm going to have e to the 4, replace g of x with an x, and there we go. And if I'm not sure, right, if I think I might have made a mistake or I'm not really sure what the heck I'm doing, it's okay because then I can do this step forward and make sure I get back to the same thing I had, right? So I can compute f of g of x by starting with f, right? And maybe I'll do it out this time. So now that I have f and g, the question is if I compose f of g of x, do I really get whatever this thing is? So if I do that, I do f of g of x by using just f and g, don't look at any of this. How does that work? Well, I'm going to have e to the 4, replace the x with g of x. I have g of x plus 5. My hope being that I then have, right, the previous step to how I got f, which I do. That's a good sign. And then I take g and replace it with what g is. So I'm going to have e to the 4. And then the definition of g is x minus 4 squared plus 5. And if I had the right f, then this thing should match what I was given as f of g of x, and they do. So I'm good, okay? So that is that. Hello. So in this video, we're going to be doing composition, but a little bit weird, right? So we're given f of g of x and g of x, and we want to know what might f be, right? So here, to do this, I'm going to start, let me maybe start by explaining. Crazy talk, I know, in an example video. So the idea is that ultimately how we're going to do this is by doing it backward, right? Normally we would be given f and g and asked to do f of g, right? So then we would do, okay, f of g, I'd take all the x's in f, place in the g of x, take those g of x's, and replace them with what they are, and that would get me f of g of x, right? So I'd have something like f of g of x, and I would do that by replace x with g of x, right? And then the next step would be replace g of x with its actual like x definition with what it is, right? Like this is the sort of general sort of layout if I were given f and given g and asked to compute f of g. So what we're going to do instead is go this direction instead of that direction in this sort of process. So to that end, I'm going to write out what is f of g of x. So f of g of x, this thing is given to me, right? This thing is, and again, to make it sort of clear what's happening here, I'm going to write it in a whole different color because it's sort of a mash of two things. I'm not sure what is what yet. So this thing is 4 times square root of minus 3x plus 3 all squared. And I'm given g of x, right? Given g of x up here. So I know g of x is square root of negative 3x. So what I want to try to do is do these steps, but in reverse. So the last step is to replace just the sort of symbol g of x, like literally g of x, with whatever g of x equals, right? So I'd find all the g of x's and replace it with square root of negative 3x. So now I want to go the other direction. I want to look at my sort of equation, my f of g of x, find anything that looks like g of x, and replace it with literally just g of x. Looking at this, I can sort of immediately see I need it, right? That's the part, right? That square root is the g of x. And really what the important bit is that means that everything else is, at least in some way, f of x. So I replace that thing with literally just g of x, but everything else is f. So that was that step. I was undoing that step. So then I want to undo this step, which is replace any sort of literal x with g of x. Now I want to go the other way. So I want to replace any g of x with x. So importantly, right, this g of x becomes just x. So, sorry, to be clear, that's the end of this computation because that's what f of g is. This is f of x. And it's this thing, only I've replaced g of x with x. And again, if I'm not sort of confident that I did it right, it's actually okay. I can check by taking f of x, right, and computing what this is with that g, right? Compute f of g of x. Well, that means I would take f of x, replace x with g, right, which will get me exactly here, and then expand, right, replace the g with what g is, the negative 3x, which would get me exactly this, right? that's that. Hello. So we are looking at composition, but we're going to do it a little differently this time. Here, we're given g of x, and we're given f of g of x, and it's asking, okay, what could be f? Or in this particular, what must be f? So what I want to sort of look at then is I want to look at f of g of x for a second, because I know what that is. So f of g of x, well, I know that this thing, sorry, it's going to bug me if I don't make the parentheses match color. We all have our foibles, people, and, well, math people have more than their fair share, and oh my gosh. Let's try that again, shall we, people? All right, so I'm going to have f of g of x closed with a clean parenthesis. Don't mind me, it's been a long day and I just get crazy. All right, so I know what this is, right? It gave it to me as this thing. Now, I'm color coordinating, but I'm going to write it in a whole different color because this thing is a bit of a mystery. All it is, sort of what I know about it, is that it's the end result of this composition. So I know that it's 2 natural log, let's see, negative 4x plus 2 minus 1 squared. Okay. Now, the other thing it gave me is it gave me what g of x is, right? So I know, in particular, that g of x is, let's see, natural log of minus 4x plus 2. Okay? So my goal then is to see, right, this is f of g. So what happened is I had some f of x, I don't know what that is, that's my goal, but I replaced all the x's with g, which means sort of ostensibly, like in theory, on paper, it should be the case that g then, this thing here, shows up in this expression somewhere, right? Because I had an x, I replaced it with g, which means g should be lurking. So doing this in general, I will say, is very, very difficult. So they sort of have to be sort of nice-ish problems for you to be able to do this. But nonetheless, to do this, I'm looking for this sort of pattern. And it turns out I can see it right here, right? So what I want to do is sort of what I would normally do if I were computing this and I knew f and g, right? I'd replace the x with g and then I replace g with what it is. I want to work backwards, right? I want to do the same process but backwards. So I want to identify what g is and replace it with g. Because what that tells me is basically everything else is f, right? So I'm going to end up with minus 8, the 2. Then I have that g of x. And then I have minus 1 squared, right? Because I have the definition of g, I recognize that, so I'm replacing that whole thing with g, right? Like this whole bit I replaced with just g of x. So again, normally what I would do is I'd have some, right, if I were going forward, I would have some f of x, and then I'd take the x and replace it with g. Now I'm going backwards, so I want to take the g and replace it with x. That'll get me to f, right? So if this is f of g of x, what that tells me is f is this thing where I replace g with x. So importantly, I'm not going to write equals here. What I'm going to then say, like, this is the end of that computation, to be clear. What I'm going to say is f of x then is this thing where I replace g with x. So I'm going to have negative 8 2x minus 1 squared. Okay? And if that's true, right, I can check this by computing f of g of x, because what should happen is I'd take my f of x expression, I replace x with g, which would get me exactly this, and then I replace g with what it is, which would get me exactly this. Okay? So that's how that works. It's worth mentioning that, like, must is a strong word here, because technically there are other options to make this work, but they're sort of dumb options. So I'm not going to go into that really. But for all intents and purposes, this is how that goes. Okay. So just as a note, like it might be an interesting exercise for you to see if you could come up with other answers, but you don't have to worry about doing so. You can just go with this. Okay. So that's that.